Hello, future awesome people. Not saying you're not awesome today, you're just going to be more awesome in the future. All right, so we're going to go over algebra, and it's going to be lesson 1-6, and that's multiplying and dividing integers. Make sure this title is in your notes. I'm going to step off to the side. Make sure that you copy this down. If it makes sense, move on. If not, make sure you listen to me. So let me get out of the way. Okay, so this is copied down on your paper. Now, with multiplying and dividing integers or positive and negative numbers, it's different than adding and subtracting, okay? Different game altogether. And watch, take a look. So if you have the same sign, that used to mean add, but that's a different game. This is multiplying and dividing. The same sign means positive, okay? And a lot of people get multiplication rules mixed up with adding rules. They're two different games, right? Just imagine if a soccer player started playing like a basketball player, right? Basketball players use their hands, soccer players use their feet. If they got those two things mixed up, it would all be crazy, right? So don't get those mixed up. So under multiplication and division, if you have the same sign, it means they're going to be positive. Now here's a little side note. This is just with maturity of your math. Is we used to write 2, we used the little X symbol for times 3. Well, then from there we went 2, and then we used a dot or point 3. And now you can actually just go 2 and then parentheses 3. Okay? These all mean times. All right, the reason we don't use this one is because that looks too much like an X, and that's now a variable, right? I don't like using the dot sometimes because if you drop it down too low, it looks like 2.3, not 2 times 3, right? So sometimes I like to use the parentheses. I won't on my examples, but just remember, if you put two numbers close together, it signifies multiplication, right? So let's look at our real two quick examples. We have 2 positive times a 3 positive. See how they're the same sign? So we still do times, right? We just go 2 times 3, you type it in your calculator, I don't care. You get 6, right? And it's positive just because these are the same sign. Where it starts throwing people off is with the negatives. So we have a 4, which happens to be a negative, multiplied by an 8, which is also negative. So we have our two negatives. But look, aren't they the same? Same sign, just like over here. Same sign means positive. So you go 4 times 8, you get 32, but this is positive. And yes, if you put negative 32, then you're thinking adding rules. Like, oh, if I had a negative 4 plus a negative 8, I'd get a negative 12. You would keep the sign. Different game. Do not get your games mixed up. Don't get your multiplication mixed up with your adding game, all right? So under multiplication, same sign means positive. So now we're going to go to the next rule is what happens if they have different signs. All right, so this is what happens when you have different signs. So when you have one is a positive and one's a negative, or one's a negative and one's a positive. So if you have if you have different signs, or if you have just one negative number in your problem, your answer will become negative. So go ahead and copy this on down. So here's my two examples. I have a 5 times a negative 4. Well, the 5 happens to be positive. The 4 is a negative. They are different signs. That means my answer is going to be a negative answer. So you just go 5 times 4 on the calculator or count it on your fingers. 5, 10, 15, 20. You get 20, but remember, one negative sign makes your answer negative. And it does not matter about the size. Look, the 5's bigger and he's positive. That doesn't make your answer positive. Over here, remember I have the more mature way of writing multiplication. I went negative 10 parentheses 2, which means negative 10 times 2. Again, the 10 is negative, the 2 is positive. Because they're different, my answer becomes a negative answer. So I go 2 times 10, 20, it's negative, right? All right, so I want you to quickly write down this next little note and write down this problem. Okay, so just to illustrate that size does not matter in math, anyhow, is I have 523 times -1. Right? It's real small. But yes, look at the answer. The answer becomes negative. Why? Because of that rule. If you have different signs, positive, negative, it gives you a negative answer. Or one negative will make your answer negative. Right? So remember, size does not matter in math class. Alright, now we're going to go into the division rules or dividing. And guess what? It's nice. It's the exact same thing as multiplication. So, if you want, go ahead, copy down these notes. If this makes sense, you understood the multiplication rules, then don't listen to me and go on forward. Alright, so this is already copied down. So we have division rules. I have already mentioned it's the same as times or multiplication. So if you have the same signs, you all get a positive answer. If you have different signs, you'll get a negative answer. So let's look at our two problems. So we have 9 divided by 3, positive 9, positive 3, same sign, equals 3. 9 divided by 3 is 3, and it's positive, right? Now, I have this negative 24 over negative 6, but whoa, that looks like a fraction. No, that's division. Okay, again, this is one of these maturity things in math. You're not going to see this in our book anymore, and here's why. Okay, you have grown up with your friends, and even your cursing or cussing has matured, right? When your friend is not being very nice, you say, "You're an ass," right? When you were 5 years old, you might say, "You're a poopy head," right? Well, this is poopy head, right? If you went around to your friend, or there was a big argument out on campus during lunch, and you yelled, "You're a poopy head," your friend wouldn't know what to do. People around you would be like, "Did he just call them a poopy head?" Right? It would be weird. So, I want your math to mature just like your cursing does. So, we used to use the division sign. Well, that's our poopy head. 24, or anything that looks like a fraction, that is division. So this is negative 24 divided by negative 6. But again, going back to our rules, negative times negative divided by a negative, same sign, becomes a positive 4. All right, now, if we have different signs, or one negative, like this one, positive 9 divided by a negative 3, even though the 3 is smaller and it's negative, it's still a different sign. Your answer comes out negative, right? But again, this is the poopy head version with the division sign. Over here, we have the more adult cursing one. We have 10 divided by negative 5. If you've noticed, the 10 is positive this time. The 5 is negative. Even though the 5 is smaller, it's still going to make our answer negative because it has the exact same rules as multiplication. If you have different signs, negative, same signs, positive answers, right? And we just have one more thing and then we're done with this lesson. Okay, so the last part of this lesson is going to be the inverse of multiplication. Remember, inverse, again, is that mature version of the word opposite, right? So what this means is if you start out with a number, which we're going to use as a variable, the letter A, if you times it by what looks to be a fraction, 1 on top of that same number, so 1 on top of the A, their answer will come out to 1. And the reason is if you go your variable, or A, times 1, you get A on top of that A, and A over A, or anything on top of itself, equals 1. So if we look at our example, it follows the same format. So they give us the number 5. The inverse of 5 is 1 over 5, or what we say is 1/5. If you multiply those together, they basically cancel each other out. Because you go 5 times 1 is 5. You put on top of that 5, 5 over 5, just kind of like the A over A, equals 1. And this comes in handy in the future, because if you have the same number top and bottom, we can actually just cross them out. If we have the same letters top and bottom, we can kind of cross them out because we know they become 1. And then if we have a negative number, so say they start off with a fraction, and they give you -1 over 9, right? So the number is 9. The inverse, or the opposite of -1/9 is a -9. You see how, again, if you multiply -1 times a -9, same sign, right? 2 negatives become positive. So that becomes -9 times 9 is 9 over this 9. 9 over 9 equals 1. Okay, so that's your inverse of multiplication rule. Okay, and I want you to know this one definition. It's the word reciprocal. Okay, and reciprocal is basically the inverse, which we know is the opposite, of a fraction, or in the non-math term, you just flip it. So here's how it looks in algebra. If you have the letter A over the letter B, or the variable A over B, if you take it and you flip it, and you get B over A, and then you multiply. The nice thing about multiplying fractions, you just multiply straight across. So I go A times B, so I get AB, because they're close together, that means times. And then I get BA, so B that close to A means times also. And now remember, just from a second ago, I told you, if you have the same letter on the top and on the bottom, they cancel out. So that A over A, that's a 1. B over B, well, that becomes a 1. So what are you left with? 1. So reciprocals will always equal 1. Here's 1 with numbers. Makes a little bit more sense. So we have 3/4. If you take the reciprocal, you flip it, the 4 gets on the top, 3 gets on the bottom. So that's a reciprocal. And on this one, if you have a -1 over 2 or -1/2, you flip it, and you get a -2 over 1. We could actually just call that a -2. You don't even have to put the 1 on the bottom. Okay, so these are reciprocals. And I just want to make sure, because that is going to come up later in math. Make sure you have all these notes. I'll step out of the way for a second. All right, there you go. And you know what type of day to have. A math-tastic one.